after, so let's get going. Anybody? I had a few things, but I'll defer to anybody else who wants to share or update what they tried and any interesting observations, results, or issues they faced. I'd like to give the chance to other people to go first if they have something they want to share in this or discuss. Anyone?
So I was able to submit the USC results from the USC notebook, and it gave really horrible results. Yeah, that's the update from my side. I think there is no way around actually training on the data set and submitting.
Yeah, that's actually, that's related, Gautam, to what, so I tried two things with your notebook that you had shared, and I wanted to kind of share, so was the score in the kind of like the 0.95, 0.9 kind of range?
Yep.
Yeah. So let me share my notebook and kind of discuss what Gautam is mentioning. And then I'll kind of point to a couple of other things related that I wanted to try. Okay, let me know if you guys can see.
Yep.
You can see the notebook, right?
Yep. Yes.
Okay, so this is essentially Gautam's notebook. So the simple thing I did, which probably, Gautam and Dinesh had both pointed me in that direction already, was that the nans were causing problems. So I just replaced the nans with empty strings and did the cosine distance. And that's essentially my first attempt. And as Gautam just mentioned, if you look at, oops, not that one, my submissions. If you looked at my submissions, the first one I submitted, and there were reasons why there are two submissions, but essentially, as it says, I was just using, as Gautam had also mentioned in previous conversation or discussion, hey, the cosine similarity itself gives values between 0 and 1, so why not use that as probability? And I think I mentioned it last time, the negative log likelihood metric means that the lower the number, the better, or the lower this score is, the better is our result. And as you can see in his, Gautam also confirmed with this, just taking the cosine distance using the universal sentence encoding, it gives results in this range, which is far worse than even the XGBoost that I just copied to make sure and reran just to see whether the submissions worked. So that's interesting, but what I also, which essentially goes to what Gautam said, that it seems like we need to somehow, or two things that I took away from this result, and I'll kind of point to one more result, which is even worse than this one, but it was just a simple modification, so I tried that as well. So one of the things that I saw when I applied, as I mentioned, I kind of made the nan values to be empty strings and then calculated the cosine distance. And when I did that with the training set, and Gautam had already done this conveniently as well in the notebook, is trying to find the best kind of threshold and accuracy. And interestingly, when I tried this with and I don't know whether you did this part too, Gautam, and what you saw, but the best accuracy was 0.73, but the best threshold, here is Gautam's comment, and this was something I wanted to discuss, that the best threshold he thought was 1 because of the imbalance, and I have a slight difference of opinion / question. But before we go there, the best threshold with this fix that it gave me was 0.78. So what I did then, just out of curiosity, was I shifted the threshold of the cosine distance so that anything above 0.78 is a 1 and anything below 0.78 is a 0 on the east duplicate scale. So I did that fix, calculated the east duplicate. I calculated what I called shifted probabilities. So the probability I shifted by saying if my original cosine distance was 0.78 or lower, give me 0. And if it's greater than that, give me 1. And I submitted that to see what the results would be, because it seemed to say that if the best threshold for the accuracy based on this code that Gautam had, it gave me a 0.78. So I wanted to try that. Interestingly, you'll see that it did even worse. This is at least in the 0 to 1, and I still haven't gone back and looked or tried to understand, but you can see the score just was far worse than even this figure. So this is my score with the shifted probabilities as the probability. So one of the things, and I'd like, all of you to weigh in on my thoughts and see whether it makes any sense to you guys. One of the things that Gautam has also done in his original notebook was plotted the histogram of the data with respect to cosine similarity. And at least to me, the reason, why he was getting earlier in his notebook when he had submitted the training data without or dropping the two nans, if I recall, the best threshold was about 1 or 0.99 or something. And here the best threshold is 0.78. But, my observation, and I could be wrong, that's why I'd like all of your inputs, is I think part of the problem in using cosine distance to distinguish between is duplicate and not is the heavy overlap you see between a 0 is duplicate and a 1 is duplicate values when the cosine distance is between 0.5 and 1. You can see how much of the data or is duplicate is 0 even when cosine distance is between 0.5 and 1. And you can see the same thing. What ideally is cosine distance, I think, was able to distinguish, then you would see 0's histogram to be much more on the lower side of 0 to 0.5, and the 1's histogram to be more or less this. But what kills it as a discriminator is the fact that, as a classifier between the two, I believe, is the fact that there's so much overlap of is duplicate 0, which means they are not duplicates, even when the cosine distance is very high. Does that make sense?
I've just started looking at this, again with Gautam's notebook, but to get things set up, I was using whatever it is, the TensorFlow page for the universal sentence encoder. I noticed on their page they use NumPy's inner product, which does like an inner product of the two encoding factors.
Right.
And they use like so they've got like some sentences or whatever, and they compare the similarity between them, but they're using inner product as opposed to cosine distance. But I don't really know the difference between the two, so at the minute I'm just running the notebook trying the inner product thing.
Yeah, as far as I recall, it's the same because inner product is just dot product, and in fact cosine distance also, if you see even in Gautam's code, right, early here, he's calculating this. Basically, because it's a matrix, he's just multiplying the matrix and then summing them row by row and then dividing by the norms. So it is the inner product, the two of them inner product divided by the norms of the two either vectors,
right,
or in case of matrices, obviously take the norm of the matrices, should be identical. But
yeah.
you know, so any comments or thoughts on this heavy overlap being the reason why cosine distance may not be that? Does that make sense? Any thoughts?
I still didn't get how you got threshold as 0.7.
Oh, I just reran this code, Gautam, after I fixed the two nans on the training set. That's all I did.
Okay, that shouldn't make a difference, right?
I'm not really sure because, you know, I was surprised it made that much of a difference.
So
but I didn't know what.
Was it almost one? I mean, was it 0.99 prior to that?
Yes. When in your original notebook, and I wish I had retained that. Unfortunately, I overwrote it. But if you have saved an earlier thingy and if you run it, see, when you ran it in your original notebook, what you had done was, and I think that I had it commented somewhere, you had dropped the two values that had nans for the training set, and then you ran the training cosine similarity, and then did the sorry for the scrolling, and then did this assessment. And I saw, this part I definitely recall, your number was close to 0.99, and which is the reason that you had this comment that best threshold is 1, and you know, here, this comment, best threshold is 1 because of the imbalance. F1 might be a better metric to optimize for.
Yeah,
In the notebook I have, I've done exactly what Gotham has, and I get the same results as you do. So I drop them, but I get the same numbers as you.
Oh, that's interesting. Because I saw his, at least I saw the numbers. I mean, when I ran it, I did not drop. I fixed it by putting the two values to be empty, which, you know, so it seems to say there it aligns with what Gautam said. It ought not to change that much. So you're saying even when you drop it, you see the same best threshold of 0.78?
That's right, yeah.
Ah, okay. So that's interesting. But I just ran it as is, Gautam. Other than that one change in, you know, what Steve says is he ran it even dropping the two values which had nans and still got a threshold of 0.78. Best threshold.
Yeah, I don't think
so.
Rows would make a difference because we have so much rows. We have like 1 million rows, right? So 2 rows won't make a difference in your accuracy.
Yeah.
Yeah, maybe I'll try run it again.
Can you talk a little bit about how you're figuring out the threshold?
Yeah, he's actually just finding. He's scanning between 0.05 to 1 in steps of 0.01. I changed it to 0.045. Just he was starting actually. His code starts from 0.65, but you just sweep it from whatever a value to 1 in steps of 0.01, and then do the predictions, which is basically train the cosine similarity, and apply the sum to find out how accurate you are with respect to your predictions and what the ground truth is. Remember, this is the training set, so you have the ground truth as well. And therefore, you know how accurate your predictions are when your threshold is set to each of these values. And then you record each accuracy and you capture the best accuracy and the threshold for the best accuracy. Anything else to add, Gautam?
No. That's, yeah.
Yeah.
So there it doesn't actually matter what you set your best threshold to, sure it doesn't, because of the fact the best threshold is going to get overridden when you find an accuracy better than your best accuracy.
Yeah.
Yes, but he captures the best threshold, right?
Yeah, but the fact that you've set it to 0.5, 0.45 instead of 0.65 doesn't matter at all because that value is never going to be used.
Yeah, no, it's only when he, my point is he scans starting from that range all the way to 1.
Yeah, but my point is that it doesn't matter that you've changed from his 0.65 to 0.45 because it never ever uses that.
Yeah. Yeah, Srinivas, I think you meant to change that initial starting threshold.
Here, right?
Like Steve said, best threshold does not get used in this code, right?
Oh,
So
okay, yes, that's correct. Because anyway, you start with my, yes, he's right. But I meant to, I should have said best threshold here so that I can change it later. But yeah, I thought he meant when I was using it in the test.
Oh no,
yes,
I just meant in that bit of there where you've sort of commented it.
I'm sorry? Sorry, Steve, you were saying?
Oh, no, I just meant in the bit where you commented it out, it doesn't actually get used at that point.
Yeah, yeah, it does get used inside here. My intent was to provide a value and then kind of use it here, but I didn't make the change where I've highlighted it to say best threshold so that, or it shouldn't even be best, it'd be starting threshold for that. But anyway, you're right. But going to, so after finding out that this is my best threshold, I use this threshold to threshold my test results, right? Meaning this is, remember what Gautam had done was rename the cosine distance thing as is duplicate. And then, so in the shifted probus, what I did was I used this column and applied the threshold of 0.78, which, through this earlier code we had identified was the best threshold, meaning the threshold that gave the best accuracy on the training set. So assume that applies for the test set as well, and applied it to this data to get the shifted probus. And then I submitted that result, and you saw there what happened. I mean, I got even worse results.
But what do you mean that you used it as the score? Did you use it so you absolutely thresholded, so your submissions were either 0 or 1?
Yes.
Because the submissions, they're meant to be probabilities, aren't they, of how
yes.
you think it's going to be 0, 1? So is it not that you just use the duplicate values without any thresholding?
No, I actually converted them and then I provided the values as the shifted, and I made them 0 or 1, 0.0 or 1.0.
Yeah, but they're meant to be probabilities, aren't they, of how confident you are of thinking it's a duplicate? So you've gone to like the real extremes.
Yes, I went to the real, I mean, I could make it, I just, again, the intent was to play with it to see if I thresholded it there and made it 0 or 1. I mean, I could make it 0.1 and 0.9. It doesn't really matter. I was just trying, if I made it binary at that point, then what does the score, does my score improve or does it get worse? And it gets far worse. Now I might, I can try with go ahead.
I mean, even if you had included the threshold value instead, right, of 0.7 as your value, just as your guess, you'd have got a better value than if you just did 0 and 1s. Right, because it's not expecting 0s and 1s, it's expecting a value between 0 and 1.
Yeah, I don't know that. That's why I said, I mean, if I made 0.1, 0.9, I don't know, maybe an incremental better score. But my point is, I think it would still probably be worse than the direct use of cosine distance. And part of the reason I felt, and this is what I wanted to kind of take, yes, I mean, and you could play with it and make the, because what we are doing when we say just use the cosine distance as a probability is basically, it's just saying, again, greater than 0.5 is 1 and less than 0.5 is 0 is the direction it would head in, because the lower the value of is duplicate, then, when you calculate, remember we are getting scored by the negative log likelihood, which just means that if this is high and the actual ground truth is 1, meaning its duplicate probability is higher than 0.5, and its ground truth is 1, then you'll score better. The higher this number is, the better your score will be, and the lower the number is for a 0 is duplicate, the better your score will be. And if the opposite is true, then the worse your score will be. That's essentially what negative log likelihood is. But
I mean, you
either
can
way,
input, sorry. No, what I was trying to say is you can, I mean, what John was saying is it expects 0 probabilities. But if your model is really good, you can just send in the results as 0 and 1. And if they happen to be perfect, you'll get a log loss of 0.
Yeah. So
if your model is that good, you can do that.
Yeah, exactly. I agree with you. So regardless of how bad my score was, it was more an attempt to say, if I did that, does it improve or does it worsen? And at least the direction is it worsens the thing, which is not what I had anticipated. I had anticipated that, okay, it might get better. Now, of course, to John's and Steve's suggestions and stuff, I can always play with making the value not exactly 0 or 1, but directionally, it's still, I think, will probably be worse, because what I'm doing here is just creating the values, and I can obviously, do whatever I want here to generate the new values, right? Using the threshold value.
What happens when you shift probabilities is, if something is slightly on the wrong side of the threshold, it becomes really worse, right? Like suppose the true value is, it's a duplicate 1, and your model predicts something like 0.4. So it's slightly less than the threshold of 0.5. And now if you make it 0, it makes it really bad, right?
Far worse.
Yeah, far worse. So that's, I mean, that's the issue here, I guess. So if your model is really, really good, in that case, maybe shifting probabilities in this way could help. But
I was, again, the simplistic thinking was, if my best accuracy is obtained at the threshold of 0.78, then using it and simply making anything above and anything below, binary classification, what does that give me? That's kind of what was my rationale. Either way, it just told me that it didn't, that direction and, to your point, Steve, John's point and stuff, it just isn't giving us or giving good results, which leads me back. I think, you started off there, Gautam, and I agree, but I was also looking, this thing is one reason I feel that cosine distance is, will end up at least using the universal center encoding, and cosine distance doesn't end up helping us in this particular task, because you can see how many of the is duplicate zeros still have cosine distance between 0.5 and 1, right? So if your cosine distance is between, again, if you're just using probability to be the cosine distance, then you are saying, in effect, that cosine distance between, and I'm making it binary to drive the point home, between 0.5 and 1 should end up giving a prediction towards each duplicate is 1, correct?
Yeah.
Do you folks agree?
Yeah, so what you're saying is in both cases, in a 0 and a 1 cases, the cosine distance between the two, between 0.5 and a 1, it's right skewed. So even if it's the two sentences or two questions, when they match or do not match, in both cases the cosine similarity is high. So
exactly, or vice versa. I'm saying because we are trying to predict, the cosine similarity being high does not tell us the correct duplicate, because it's unable to distinguish. There are lots of cases where cosine similarity is high, but is duplicate 0.
Yeah. Yeah. Plenty of cases. And it's
That overlap is causing us our inability to use cosine distance to be able to, and obviously combined with the universal sentence encoder, to be able to do well on this task. Does that? So that's at least my, and the next step is what Gautam said at the beginning, but at least why does this particular thing not work? When I looked at, and thankfully Gautam had already printed the histogram, it seemed to jump out at me. Do you guys agree, have different thoughts, disagree? That's kind of what I wanted to discuss a little bit.
So I have a question. So I think, and I don't remember if this was discussed here. So, because somebody tried other metrics, and I thought we discussed it in this group before, to use this like a Euclidean distance and Jacquard similarity.
Yes, yes, that was going to be, in fact, yes, we did touch on it, Yuri. So here's where my first thought then initially, as I was doing it yesterday or day before, was, oh, good, now cosine doesn't work. Let me try, and I didn't jump on Euclidean, which probably is worth a shot. I haven't tried it. It's simple enough to do, to where you just replace the cosine distance code that Gautam had with calculating Euclidean distance between the two embeddings you get out from use. I did not try that. That would be a good thing to try with this notebook. The other, however, with respect to Jacquard similarity and Jacquard distance, I immediately ran into a problem, because that was the one I was thinking of jumping on, because I said, okay, cosine doesn't work, cosine distance, then let me try Jacquard. But see, but for Jacquard, and I'm open if you guys have any other way, but for Jacquard, you need the components. By that, I mean, you need the encoding of the individual words, because what you're trying to do there is intersection over union is what Jacquard is. And intersection or union means the intersection of the words between the two sentences divided by the union of the words in the two sentences. In this case, at least, we are directly using or simply using the universal sentence encoder without going through word encoding type of stuff, right? So I was like, then if I'm using word encoding, then there are other ways of tackling this problem that, again, I can share that I was looking at doing as the next steps. But before we go there, I just wanted to ask people, anybody on the call, as to whether they can think of any way to use Jacquard distance without going down to the word level. Because as soon as you say Jacquard, then I realized that we would have to have word embeddings. Because that's where you can do the intersection over union, and the distance is 1 minus that. But, you know, all that is detailed. The bottom line is you need individual word embeddings rather than just using the sentence encoding. Any thoughts on that?
I mean, not even the word embeddings, right? You would just use the words as such to calculate the Jacquard similarity. Or am I wrong?
Yeah, you could, yes, you could do that. You could just count the intersection of the words in the two sentences divided by the union. Yeah, you don't even need the encoding, but you would have to do the words part.
That is the only way, right? Is there any other way of doing Jacquard similarity?
No, that's what I was asking. That, to me, that's the only way, right? You'll have to go to the word level. So that's why I was wondering whether.
I guess the appealing thing to do would be to do both embedding and Jacquard similarity, because if somebody uses synonym, although like synonyms actually not always have the same like the same embeddings, but if we're assuming that very similar words have similar embeddings, then
right, then you would be closer in the embedding space than just a word count. Yeah, that's a good point as to why to use embeddings, because the embeddings you would think have similar values in the embedding for synonyms. That'd be interesting to try both and see how different they are. Just count the words as Gautam is saying, and also do like a glove embedding. But bottom line, I was just wondering whether, you know, as soon as I saw that, I was like, oh, we do need to then start counting the words and doing that. And I just wanted to make sure there's nothing else or no other simple way that I'm missing. So that's essentially what, you know, is kind of same space. I think the next things definitely with this notebook would be to try what we've discussed, which is Euclidean distance. As Yuri just pointed out, that would be a simple enough change to the cosine distance code here, replace it with Euclidean distance code, and then add code in the beginning to do the word counts, to do the simple word count intersection over union that Gautam mentioned. And the second approach on that, in that direction, would be to, you know, to pass the words through an encoding and then do encoding union. Actually, in that case, you would still do the, just thinking, if you use encoding and the Jacquard distance, it would still be similarity. You would still default to what Gautam is doing though, Yuri, right? Because, or what Gautam had suggested, because you're counting, in an intersection sense, there is no way that you can decide that two vectors are close enough that you're going to count them as the same.
Hey, Gautam, can you just talk a little bit about your word count method? Because that doesn't make sense to me.
No, I was saying Jacquard similarity as a metric can be used only when you look at the words, when you just look at the number of common words between question 1 divided by the total number of unique words in question 1 and question 2. That's a simple metric, right? And you cannot use Jacquard similarity when you are when you use embeddings. It's no longer possible.
Ultimately you have to default. Go ahead.
I think at best Jacquard similarity can be used as a feature in a bigger model. It may not be a good indicator itself of duplication.
Yeah, so in that case, we are calculating per question. So, and then we need to remove those stop words. So that will leave a very less number of words in a question 1 and a question 2. Is that correct? So I'm assuming here that we don't train on a whole corpus. It's simply you just remove the stop words, you just tokenize it, wouldn't do any embedding, and just then start counting those tokens in a question 1 and a question 2, and find out the unions and intersection. Is that correct? I
would tend to think what you're saying, and there are, if you poke around, there are many notebooks which do that in the exploratory data analysis, that you can just put to reuse that or use that as a starting point and that.
So how is going to be different with the TF-IDF? Is it TF-IDF is for a whole document we do, or we do like on a question 1 or a question 2?
You could use it for a sentence too, but that exactly takes me to what Gautam said at the beginning, and I wanted to share a couple of different ideas, at least that I was thinking of applying. And feel free, anybody else, to jump in and add your 2 cents. Let me share I'll stop sharing and then go to a different window of mine, so you'll be able to see a slightly different idea, at least 2 ideas that I thought, beyond using the Jacquard word collection with the universal sentence encoder. Gautam said something which I thought was very insightful, which is where I was headed also from what I could see, that if you need to kind of train, and maybe the universal sentence encoder, which, it's a model that is already built using it's trying to encode the meaning in the sentence. And maybe we can start off with simpler variations of what it does. So I'll stop sharing and switch to a different window. Give me a second here. Okay, can you guys see my screen?
Yep.
Yeah.
Okay, so this is one of the papers or not papers, but one of the blog posts that's referred to in the various notebooks and discussions that I thought was fairly simple and is worth a shot as a baseline. Beyond what we were already playing with, thanks to Gautam's notebook. So this one says, the suggestion here is to use a very simple approach. I'll post a link to this on Slack after the meeting, but it's a simple approach to doing this text pair classification. And so here, he's using what he calls a neural bag of words model. And I'm going to skip over this because this particular part where he talks about the decomposable, we'll come to that maybe as a subsequent or a more enhanced version. Also, editorial comment, he uses spacey and some, remember that this is a little bit dated. I think the post was made in 2017. So he uses spacey and some unique capabilities in spacey. None of that, I think, is material to what approach that he is talking about applying. So, and he, in this case, he just uses a neural bag of words or essentially a bag of words and then applying it to a neural network. And what he does is for each sentence, he just builds up, if you will, an encoding and then does mean and max pooling of the words for each sentence. And then concatenates them. For by them, I mean you get the mean, you get the max for each sentence, mean and max of the encodings for each word in the sentence. And that's for sentence 1. And then for sentence 2, you concatenate all of them and then you pass them through a simple max encoding, a simple neural network with a max out layer. And I didn't know what a max out layer was, but apparently it turns out it just picks out the maximum value from what you send it as an input. And then he applies a softmax to that to get the result. And impressively, he gets fairly good accuracy from even as simple a model as this. So to repeat, and he has a little more detail, he takes, the basic encodings, which are 300 wide, and shrinks it to an encoding width of 128. I don't even know whether I was planning on implementing it without this further shrink. Just take 300. I mean, it's not like computers are incapable of handling 300 width. But I was just going to simply use what he did, which is for every sentence, meaning for sentence 1, find the encoding of each word in the sentence, do the mean and the max of the encodings. And for sentence 2, again, find the individual words encoding, do the mean and the max. Concatenate the 4 results, send them through a neural network which has this max out layer followed by a softmax. And whatever the softmax outputs is duplicate value. And check whether that does. So you train the model using the training data and then apply it on the test data.
Okay, so when you say take the mean and the max, so you got a sentence, you take a word, and then you're doing a mean and max of what?
So you sentence, you take the word, you get its encoding.
Yeah.
Right? So you have, let's say, a sentence of 5 words. Yeah. Each of the 5 words has an encoding. So yeah. Find the mean of the 5 and the max of the 5 words in that sentence. Mean of the 5 encodings. Mean of the encodings of the words in the sentence. And the max of the encodings of the words in the sentence. Okay? So if you have 5 words in the sentence, you would get 1 mean from the 5 words encoding and 1 max from the 5 words encoding, concatenate them. So you have like 2 values that you have concatenated for sentence 1. Similarly, go to sentence 2, do the same thing. You have 2 additional mean and max encodings that you concatenate. So you now have, let's say the original encodings were 300 wide. You now had 1,200 wide encoding because you've concatenated 4 values, right? And then you put that through a max out layer and then a softmax layer and use that as your output of is duplicate or not. Again, a fairly simple thing to build, and I just wanted to see how good of a result it gets from this simple approach. If you wanted to get a little bit more fancy, you can do what he's suggesting and bring down the 300 to 128 by taking it to another layer and stuff, which I wasn't going to bother to do because my interest is not so much in you know, how fancy I can make this method as how does this method even yield. It seems very simple and quick to build and see how much better or worse than the cosine distance thing that we played with and some of the results that we have seen posted by people already. This seems like a fairly simple approach to apply and see how good of a result we get. And the next step with this approach itself, if you want to get more aggressive, and it seems very interesting, is what he calls the max out window encoding. And in this case, what he actually is doing is instead of just taking a single sentence and figuring out the mean and the max, he tries to emulate bidirectional LSTM by doing it on 3 sentences: the sentence before, the current sentence, and then the sentence after. So you would do it on sentence, let's say you have a sentence pair number 5, then you would do it for the sentences at index 4, at index 5, and at index 6. And that's a window, 4, 5, 6, a window of 3. And you can read the details, but that's another approach which, by the way, if you read the blog, he says initially that it didn't give him any better results, but then he corrects himself by saying there was a bug in his code, and actually he does get good results. And if you see the accuracy results he quotes on the Cora database, it's better than the accuracy that we saw when we played with Gautam's notebook, because the accuracy is 83, 88. Gautam, if I recall, the best was in the 70s. Is that right?
Yeah, yeah.
78, was it? Or 73 or something in the 70s. It's my recollection. So I thought this was, you know, not too aggressive, but fairly easy thing to try. You don't need to build an LSTM and stuff. You just concatenate, you use the glove vectors, download encodings, use the encodings, find mean max. You know, you can stick in a min if you want. You can do min, mean, and max. So you'd be kind of sticking 3 encodings concatenated for each sentence and try that. I thought that was simple. He refers to it as a baseline. I would tend to agree that this is not going to give the best score potentially, but I thought it was a good, simple baseline to set up and see whether it gets better than what we have seen so far. Any thoughts, comments?
Yeah, I have a question and a comment. So the comment first, I'm looking at the blog also. It's so the guy is actually, he's a Spacey co-founder. I don't know if you saw that.
Oh, okay. I didn't. He has used, you know, he used Spacey's some specific early approach. They might have even made it better by now, but I didn't feel that was necessarily important that you use that to do what he's suggesting. But it seems like his method seemed fairly simple, intuitive, and very good to set up a baseline. But yeah, no, I didn't see that. Good thing you pointed that out. Interesting.
And the question is, I'm still like, can you, how do they, like, so you have example of 5 words in a sentence. How do you create mean and max? Is it like mean of each, like a minimum of each element of the vector? Or?
Oh, no, you just mean and max the entire set of vectors which represent the words in your
how do you compare vectors? How do you compare?
Oh, you just do the mean of vectors like you would do the mean of any, so, you know, like 300 dimensions. So you just add them up and divide. So it's an element by element add, and then obviously total divide by 5.
Okay, that's average. And how do you do maximum? You add them together?
Max is just the max of, that's a good question. I think the max, you have to look at how tensor maxes work when you compare tensors. That's a good question. I haven't looked at that, whether it does max by computing element-wise max, or when you do a max of any set of vectors, how it picks the max vector. Because some could be smaller, and meaning some individual
presumably be element-wise, right? You'd expect it to be element-wise. If you're doing it for the mean, that way, then it would have to be the same for the max.
Yeah, the thing I was wondering is, you know, if it does element-wise, and it just ends up with, let's say it's 300, and you find, you know, 150 are lower and 150 are higher, what it does. It says the two are, you know, it just picks probably a random between those two at that point. Or maybe it does the subtraction and figures something out. But that's a good question. I would also be interested in knowing the details of how it does the max.
Can you expand a little bit on why you think
I agree. Go ahead.
Can you expand a little bit on why you think this is a good intuitive first step? Because this is not, it doesn't ring as being very intuitive to me, taking the max and the mean of these, of your embeddings for the sentences.
Sure.
Can I say something? I think that's how a lot of people calculate sentence embedding. You take the mean. You take the mean of like sentence embedding, and they at least before like when you I think before like dedicated sentence embeddings, that's how you were calculating embedding for the sentence. You were just doing mean of different word embeddings, and that was like a decent approximation.
Yep. I agree with what Yuri said. So here's what the way, John, that I think about it, to Yuri's point. If you look at the spectrum, one spectrum we have today is like after the transformers, the BERT, which is again, if you expand BERT, it says bidirectional encoding representation with transformers, right? So it again is a embedding, it's a bidirectional embedding, and it uses transformers to represent the BERT. Word, again, not sentences. But to Yuri's point, I think where my intuition has, you know, before the transformers and other things came around, was the following, that by taking the mean or by the max, you're kind of finding out, and if, in fact, if you, for those who went through the CS224N class, somewhere in the middle of the class, as he begins to get into the CNNs and you know, the conventional convolutional neural networks and stuff, he begins to kind of try to figure out how do you find the meaning, let's say even in translation or for anything where you want to find out more than the meaning of a word, how do you try to find that out? And one of the very simplest ways to find out the meaning of something which is more than just a word is exactly what you said. Then you just find the mean representation of the words in your bucket or sentence. In this case, it could be, instead of sentence, it could be a paragraph, it could be a document, which is the reason that I was telling Dinesh earlier that TF-IDS, that also leads to this kind of, because it's basically a neural bag of words. So you use your sentence as a bag of words, and you say, what do these bag of words most likely to represent? And you find something which now, and this is where you're hedging your bets by computing both the mean and the max, which is saying, I don't know which of these two is going to give me a better representation of this, what this collection or the bag of words in this sentence is going to mean. So I'm going to take the mean. I'm also going to take the max and let the network figure out which of these two is better representation of that sentence. And I'm going to do it for both sentences and then have the network figure out and learn whether it is able to say the two sentences convey the same meaning or not. So that's why, to me, it's intuitive, because that's what eventually leads to BERT and other more complex approaches. But this is a very simple approach. It's likely not going to score very highly, but as at least from the numerical numbers we saw from his posting, it seems like it will score better than what at least, we've seen so far.
Okay,
I was just thinking, but so if we still haven't tried to put constant similarity if we do the neural network also, it might score way better if we do that.
Maybe. Yeah, that's worth a shot. Especially if the thing is uncorrelated or, doesn't worsen it. So it may be worth setting it up as another input if that's something that we'd like to do. You can provide that as another vector into the only thing is you need to make the dimension of, well, actually that matters since you're concatenating. But so you could potentially throw that in as well.
And I think a fair comparison between this, what Spacey has provided in this blog, and USC would be like when you take the USC embeddings of the two sentences and you train that as well. Like you could concatenate the USC embeddings of the first question, second question, and form a simple neural net and train that on the data set. And then you can compare
on
this.
The training. Yeah, that's a very good idea too. Basically take the two embeddings, throw it through maybe a couple of bends followed by dropout or something, and then train it on the input data and see how good that is.
Yeah, and I think essentially that's what they're doing here, right? They're using mean to get a sentence embedding, and they're concatenating those and getting a network. Yeah.
Correct. Yeah. So that's another change you can make to Gautam's notebook and play with and get. That's good thought also. So we are about an hour, but before we end up, I just wanted to point to one other approach. This is a little bit more complicated, but it seems like before BERT and the universal sentence encoding and all that showed up, this was a way or kind of gave the state of the art or a very good, was thought of as a significant contribution. And that's the whole idea around skip thoughts. And again, I'll post this link, and we don't, can people hang around for 5-10 more minutes, or should we defer it to the next meeting? I can kind of in 10 minutes give you a very quick overview of what this does, and then you guys can read and we can discuss, because this is another implementation approach that can be done. If people can just hang on, I can maybe very quickly, and this blog is very well written because it is written in the form of question and answers. And in the interest, please do read it. It's fairly explanatory, self-explanatory, and I would encourage you to read it. And here, what is fascinating is he uses an encoder-decoder structure to train the network, throws away the decoder, and the encoder basically is what Gautam is using. You can think of the universal sentence encoder replacing this encoder. That is, and then using the encoder part to generate the sentence embeddings, which then are used to predict. So encoder network, a decoder network, but the decoder networks are two. And what's fascinating is you use previous sentence, the current sentence, and the next sentence, and to use the encoder-decoder structure. He talks about how it is trained, and as I said, it's almost like training an analog, not exactly the same. I'm sure universal sentence encoding is much more nuanced, sophisticated, because it's modern, meaning this is again several years old. But given that it gives us practice to build LSTM networks and understand how an encoder-decoder structure works, this I thought was another interesting, and this is based on a paper of a few years back of implementing an encoder-decoder network to figure out the sentence encoding, and then using that to predict is duplicate or not. And what is fascinating here is, for those of you familiar with BERT, this skip thought vector approach is also using a similar approach to BERT, in the sense that it's trying to predict words from the previous sentence and from the next sentence using words in the current sentence, which is somewhat mind twisting that it's able to do that. But nevertheless, read this blog post for it. I think it does a good job of taking you through the steps of using or building skip thought vectors, which are essentially the output of what Gautam has used of the universal sentence encoder. But you can kind of think of this approach as building a very simple version or a very primitive version of what is probably built into the universal sentence encoder today. I thought this, if you wanted to be aggressive, would be probably an interesting next step beyond, and he has already given a GitHub implementation as well. For this would be a good next step beyond the previous discussion we had of, sorry, not that one, but this guy, the deep text pair classification. So I just wanted to point to that before I posted it on Slack as well. So, in essence, as to summarize, at least many good ideas to try, right? We could try the Jacquard by just doing the word counts. As Gautam pointed out, we could take the universal sentence encoding output of each of the two sentences, and that he already has shown us how to get, and then throw it into a network, into a neural network, and try to build that. We can use the spacey approach I'm pointing to and concatenate the mean and the max and try to get that output and throw it into, again, a max network or your favorite neural network and a softmax output to get each duplicate. And if you're feeling even more aggressive, you can try the skip thought vectors and build what he's talking about, the encoder there. So many things that we can try to kind of improve the score of what we are seeing currently. Any thoughts, comments, people want to add before we wrap up?
So really quickly, so I think the two approaches basically require more than one pair of vectors. I think it was the first approach you described where like they take 3 sentences or 3 pairs, and then in this approach it's also like it looks like they rely on multiple pairs. Do they have to be related, or you think those are random pairs?
No, just in fact, that's the thing which kind of was to me remarkable, that they're not pairs, they are just sequences that follow, like think of it as just indices into the sentence 1 list of sentences. So, and by the way, what you said is correct, but only when you go to the more complex implementation of this this approach. The basic approach where you just calculate the mean and the max, that doesn't require any windowing, so to speak. That's just for a sentence.
Yeah.
But there is a version here he talks about, which is this Max Out Window Encoding. There, what you say is correct. And there, the sentence list is the list of sentences from the same, think of it as, if we think of sentence 1 and sentence 2 as the 2 lists of sentences that we are comparing, then I-1i and I+1 are, if I recall, all of sentence 1. And of course, on the other side, you'd have, all of sentence 2, but that's my recollection. And I'm sure of that in the skip thoughts as well. That is, these 3, right, are, if I recollect, just sentence, think of it as sentence 1, sentence 2, sentence 3, all in the, all of, or I should say ID1, ID2, ID3, and this list is just sentence 1 list.
Okay, so unrelated sentences, basically.
Yes, that's correct. Unrelated. And that's the thing which, to a certain extent, at least to me, was like remarkable. Because what the decoder is being asked to do in this case is to predict the words of sentences that are unrelated to the current sentence, the previous and the next. And obviously this whole thing is trained by a loss and then propagating it back. But that's how you get the encoder to become smart enough to encode the meaning of the sentence in ZI such that the decoder is able, this decoder is able to predict the word in the previous sentence, and the next decoder is able to predict the word in the next sentence, which means that this encoder has to be trained through the loss from these 2 decoders matching stuff to generate the ZI such that it really does a good job of encoding the meaning of the sentence so that it is able, so that these decoders are able to predict this. And if you read through the blog, that's what is, and yeah, pretty remarkable. And then when you're actually applying it, for example, for our purpose, you throw away these decoders, you just use the encoder and the output to generate that, which is, to me, equivalent to the output you would get from the universal center encoder that Gautam has used. But so in that sense, it's almost like we are learning through this approach to build what's inside. Of course, that's not precisely accurate, because I'm sure, as I said before, that universal sentence encoder is probably doing a much more complicated job with modern approaches. But here it's just using LSTMs and maybe bidirectional LSTMs. But at least we know of the techniques to use to build such a sentence encoder, which is along the advancement path beyond just taking the mean and the max of sentence values, word values, I should say, word encodings. So that's why I like this as the next step along the path of trying to get more complicated in the approaches. So lots of things to try. Probably will take us more than definitely a week or two, but at least it gives us a good slew of ideas to go out and try and implement and see what results we get. Anything else to share? Thoughts? Guys? Okay, thanks a lot for joining. I'll post a recording. As Steve mentioned, I'm traveling across to India shortly, starting tomorrow morning. I hope I'll be able to join with no problems and run the meeting from there. If not, I'll reach out and let you folks know. Somebody else can host the meeting on my behalf and I'll provide the detail, but I'm hoping won't be necessary and that I should be able to take on the task from there. Thanks, everyone.